So in this question, we have a student in an experiment, two-object system. Before and after a collision takes place. So there's some speed that block X has. It says they are identical, and that identical means their masses are equal. Is initially at rest, so V0 equals 0. And there's no friction between the blocks and the surface. A second experiment, which the magnitude of the force in XY is measured over time. Graph of the force as function time is shown. So we've got an RGA analysis. Actually, we've got a whole OA-zerga. Our origin is 0, 0. Y-axis is force in normal units. X-axis is time in normal units. So therefore, any questions about force and time will be read off. The slope, or the gradient, delta F over delta T, which is the rate of change in force. And the area is F delta T, which reminds us of J equals F delta T equals delta P equals M delta V. So there's a lot we know from the area. Graph is shown. Third experiment, collision such that the force X and Y is constant for 0.02 seconds. Which of the following constant forces would produce the same change in momentum as that shown in the graph? So the change in momentum is the area under that curve. So we want to know basically what would give us the same area. Which constant forces would produce the same area? Well, we can see the maximum force is 800. What we're looking for is an average constant force that would produce the same area, and that would be 400. We need to produce the same area, and that is going to be F max over 2. And of course, you can see then that this area should be equal to that area, and this area will be equal to that area, rounding out the triangle. So we need 400 newtons, choice C. That would be the correct answer if we were doing it in the same time, would be 200 newtons. 400 newtons if the same time. And what we should notice in this question is it's 0.02 seconds, which is twice as long. So what they're now talking about is if that's 0.01, 0.02 is over here. So we have this like so, and we need something that's going to produce the same area as that. And if it were the same time interval, it would be this 400. So then it probably stands to reason that if there were a constant force this large over twice as long, then we'd have the same area. So you can see that gray area, that brown area, would be equal to that. And of course, these yellow are shared between this rectangle and this rectangle. So therefore, those areas are equal. So if we're going to be doing it for over 0.02 seconds, it needs to be 200 newtons. 400 newtons if 0.01 seconds, 200 newtons if 0.02 seconds. So the final correct answer is 200 newtons.